Vincent, Ken, ladies and gentlemen, great pleasure of mine to be here, especially among the very young people. I think the median age here is around just 30 or less. I think I'm probably one of the oldest guys in the audience. So tonight I'm going to talk about my experience, but before that I have to declare my conflict of interest. I am on the board of director of this company, AstraZeneca, Insider, and also HKLSS. Now, I'm going to talk about before, after, and exit plan. Now, why do I want to do that? It's just to share with you my humble experience walking through science and how do I end up the entrepreneurship and end up where I am today. So first the before, but before the before, I would like to ask, if you have a master's degree in science about, can you raise your hand? I want to see. Okay, good number. If you have a PhD, please raise your hand. A good number as well. Any one of you who actually own or running a entrepreneurial company or a startup right now? Okay, that's a good number. And I do see there's a few CEO around here who can fund you guys. Now, I want to say this is the first statement I want to remember, if everything I say that you can forget. The science of today is technology of tomorrow. That's why we gather here today. We are making science, we're interested in science, but the question is that science is good for humankind if we can transfer it into technology. Now, but in that case, you say that, okay, but I'm making science in academic, but do I really have to commercialize it? The answer is probably not. We have to make science for the sake of science. Science is to ask the question and to seek the answer. That is our basic fundamental principle that we are hold to. And also, I have to tell you one thing is that most of the time, most of the publication we make, even in Science and Nature, it will not be converted into something that can apply into technology or commercialization. So one good example, Alexander Fleming, he found penicillin. Or, you could say that, this is the first antibiotic in the world. He could become a billionaire based on that. But he ended up quite poor. Working in UK, he never found a company. The drug was eventually developed in the Second World War, commercialized by 4 different companies in the United States. And so those companies make the money. Alexandra didn't make a sense out of the discovery of this very crucial antibiotic. So I'm going to share with you my little journey on EGFR mutation. I work on lung cancer, you probably may know, and EGFR mutation is one of the first driver oncogene that actually determine the treatment for the patient with lung cancer. How did I get there? Well, first of all, I was educated in Hong Kong at St. Stephen in boarding school. I won't go through the detail, but I went to Canada, get my medical school, become a specialist in oncology in Toronto area. But I had once thought about becoming a scientist as an oncologist. So I was in the resident, finishing the fellowship, and I want to say maybe I should do academic. But you know what happened? Well, I didn't learn enough about birth control. My son was born. So as a result, being a father of a young child, I decided to say, what the heck, I'm not going to do the PhD with only a poor salary. I'm sure some of you know how much you got paid as a PhD student. So I went into a community oncology, as a community oncologist in a small hospital called the Scarborough Grace Hospital. It's nice because there's a lot of Chinese there. I'm the only Cantonese speaking around the region, so I got a lot of patients. Good business. However, the work get a little bit mundane. So I won't tell the detailed story. There would be another talk if you invite me back, is how I get back to Hong Kong. But I actually end up to the Prince of Wales Hospital by chance as an assistant professor in CUHK in 1996. It was a totally different story, but I don't have enough time to tell the story. So I come back, and 1996 is now 2026. So when I first come back, I actually had 0 publication. Now, for those of you who are in university, publication is like money in your pocket. If you have 0 money in your pocket, you feel quite poor. And I was 36 at that time already, probably older than most of you around here when I first started my journey. And then there's another problem. I didn't even know what I want to do. At that time, Hong Kong was popular for NPC and liver cancer, but it's already taken up by other professors. I would just say, there's nothing happening in lung cancer. Why do you take up lung cancer? So it was just say, 豬頭骨, nobody won, and you just take it up. So it took me a number of years before I get my first publication in lung cancer. And then after that, I got on my journey of DGM mutation. But maybe ask the question, when did I start thinking of, hey, maybe I should start a company? The answer is that I never thought about it. I was just converting from so-called the clinical practice into academic. I was thinking how to build up my science knowledge and build my research. Never thought of a company, but only by chance, I started a company in 2015. And that is a part of the story. I'm very glad to see Tony Mok is here, because Tony is actually the person who helped me to work on that. I'll tell you more about him later, good and bad. So let me just go back to lung cancer. Lung cancer is a terrible disease. Number one killer among all the malignancy is silent, because your lung is intrinsically lack of sensation. Only in the pleura and airway you feel it. So even the tumor become big, like 2-3 centimeters, you don't feel it. Are you sure you don't have a lung nodule today? Quite sure? You had the CT scan done? Not yet, exactly. So that is exactly how silent and how risky it is. So, but then there is a discovery of the EGFR pathway back in the 60s. They worked out that it is actually a so-called a receptor on the cell surface that gives the signaling pathway to the nucleus and promotion of the proliferation of the cell. I won't go through the detail. So people start to target EGFR. So they get first drug is called gefitinib. So they did clinical research almost like 20-some years ago, but the result was disappointing. Response rate in the Japanese population, 20%. In the Caucasian population, 10%. How long do they last? 2 months, 3 months. Absolutely terrible. This day, if you do drug development, you just throw in a garbage can in no time. But there's something different. Occasionally, there's 1 or 2 patients who have dramatic response. Picture like this. This is one of the first patients by Tom Lynch in the MGH. There's a picture we share that the tumor was extensive, but within weeks, it cleared up. Those are the dramatic response lead to the further investigation of the drug. But then we did not understand why it worked. So only, but then they did another study to say maybe just compare it to see what is better. But then in the randomized study, it's also terrible. It's not better than placebo-controlled, not too much. And the response rate only about 10%. Absolutely failure. But this study gives us some hints. Asian seem to be better. Non-Asian, no different. Asian, there's some different. So only about in the year 2004, there is an investigator by the name of Tom Lynch and also Pasiani. One is from the MPH, Pasiani is from Dana-Fiber. They just thought, hey, maybe we should do the mutation, to do the sequencing of the EGFR gene. And long and behold, they did 11 cases. All 11 cases in either exon 19 or 21, there is a mutation. So all the dramatic responders are related to a single point mutation. They reported this in Science and also New England Medicine respectively, and they presented this in ASCO. I was in the audience, and then I say, Fatalo. Because I knew about driver oncogene from CML and JITs. The first one is the BCR gene that they use a drug called imatinib that dramatically changed the patient with the CML. And so I thought, this is exactly what we need in lung cancer. So with that, with some luck, we were able to do the first randomized study led by CUHK around the Asia area with about 1,200 patients, demonstrating that if the patient have EGFR mutation, the targeted therapy is better than chemotherapy. But if it's negative, then chemotherapy is better than the targeted therapy. So this is the birth of so-called the personalized medicine, and therefore we can select the treatment modality according to the genetic mutation. And so that was published in New England Medicine and cited over 10,000 times so far. So this is the beginning, but then it's not the end. Because patients get well, but it lasts for only about a year or so, they get worse again. So we start to investigate why. And long and behold, we were able to say that in the binding site, of these gene, there is a mutation at the site of T790. When it changed from T790 to methylene to T790M, then it stopped the binding. So as a result, we have to develop a new drug to bind a different site. So this is so-called a third generation drug, and we were able to do a randomized study called OR3, T790 positive, randomized neutral osimertinib versus chemotherapy to demonstrate, again, a difference. So those are the drug trial, but not really what I do in terms of so-called starting a company. But there is, incidentally, one important question. How do we find a mutation? Because lung is not so easy to biopsy, and sometimes we can't get it, and sometimes we miss it. But what if we can get it in the blood? We can get it in the blood to find an EGFR mutation and T790M, then the patient can get the drug appropriate for it. So this is so-called the concept of plasma-based biomarker selection. So that is the before. Sorry to bore some of you who do not are into this arena, but I have to give you the background story before I can tell you the after. Now the after is to start a company. Well, Gage, when you need a company, you start a good name. First thing, you find a good name for it. Lamfeng is not too bad, huh? So what does Synomic mean? Actually, Tony and together with Dennis Lowe and Ellen, we actually spend a lot of time back and forth, multiple emails just to say, what should we call this company? So turn out our so-called, not hobby, but our so-called what we like, the red wine, help us. So sangria, come from, the famous Spanish strain, mean blood. So omics, multi-omics. So from the blood, we do the analysis, so we call it Synomic. And so this is the starting with a good name. But a bit of a concept is that cancer cell grow and die. They spill the DNA into the plasma, is all well known now. And then we can pick up the DNA. Dennis Lowe is famous for development of such. Now, this is the first study. You can see Yong and Mok. That is a Tony Yong. He was a master student under Ellen Chen and I. And so, he was just a faithful student before he got his MBA and start business and those kind of stuff. He was a humble master student. And then at that time, we used a very crude technology. It's called digital PCR. Because when you do PCR, you can only do one gene at a time. But in the plasma, you can't really pick up too many DNA. So we got multiple drop in this so-called a cassette. And then we can do multiple PCR in the same time. The one that's positive is positive. So it's a semi-quantification, but very crude method that you really put it dot by dot, so not the best thing. But this was able to demonstrate in one of other study, we got a sample is that the patient who got plasma positive on the TKI is going to do better. So this is one of the clinical studies demonstrating plasma DNA is clinically applicable. We can predict the outcome by looking at the plasma DNA. But then there was a new technology. This looked quite old, but at that time, 10 years, this is new. This is called the digital PCR. And nothing big deal because it's a droplet with the DNA, and then you were able to do sequencing at the same time. But hey, we had the technology. So one thing I think is important for all of you is this. Novel technology plus clinical application is equal to commercialization opportunity. So don't just sit there and say, hey, I want to start a company. But ask yourself, what is your novel technology? Number two, especially in medicine, what is your clinical application? If you got technology, but you don't have a specific application, it's very tough. You can develop it and start to look for application. It's actually going to be risky. So have these two components ready and then go for it. But then, okay, now I've got technology, I got clinical indication, I got the knowledge, I got the know-how, but what do we do with it? So, low like right. I had no idea because I never thought of starting a company. I actually, hey, just to go on with academic and, get older, die and retire from my academic position. But what to do? Well, there's another thing very important for all these young people. You are lucky. You got mentor. You got a mentor to talk to. But I was already a professor at that time. I don't have a mentor as a professor. But you got a friend. A cup of coffee, sit down, and find a friend. And my good friend was Ellen Chen. So he's a very smart guy working with Dennis Lowe, push his NMPD into very success and then go on cancer DNA. So I still remember that we were together, just in my office talking about it. And then these are the three things. Important, get your business model, get your seed funding, get your location. Those are the fundamental of how to start a company. And for that, we got the technology. And then also that we actually had the location is that we borrowed the lab from Excellent, which is doing an NDRD testing already, a successful company. And then I even borrowed Tony Yong to outrun my company at that time. And then the seed funding was only $500,000 that we can afford as a doctor. So they built a team. And then Stanley is our first CEO after Stanley, when we become an independent company, built a small team, finance office independently once we were able to generate some money. But remember one thing, when you go to 賣魚蛋, you can never get rich. But when you 賣魚蛋, you also sell everything else, increase your chance of profitability. So instead of single testing for EGFR, we expand to multiple different testing for NGS, genomic testing. So we built up a portfolio. So things were doing quite well from 2015 to 2018. But then remember one thing when you're starting a company, please, disaster is mandatory to happen. You must have some disaster, whatever. So this is my first disaster. The first disaster is that when we first start, the shareholding is like this. Excellent, the company holds 70%. And Excellent is mostly Dennis Lowe and Alan Chen. And I hold 30% of the company. But then Barry Genomic was also a partner of Excellent. So Barry decided to buy the whole Excellent. So in other words, all of a sudden, I had to work for Excellent. I not work from Barry, which I don't want to. So what do? Because I only hold 30%, I don't have the control right. Because I thought I was starting with a friend, so I don't care. But now all of a sudden, I have to work for a company. And by then, the company is doing quite well. Well, if in doubt, expand. So that is in. At that time, we have to get new investor, including Vincent, and also from Patrick. And the process is difficult because I have to find investor. And I'm not good at it. I even talked to Vincent. Vincent doesn't like me, so that's okay. So one thing, the transition from academic into entrepreneurship, you have to work with investor. And quite often, we do not know how to deal with it. I always say that start with a nice smile. You have to convince them you got a team to work together. But you have to provide them with a big but realistic plan. But then you also need multiple people to help you and also provide exit plan for your investor. But in a summary, we're selling hope. But I'm not good at it. I can sell hope to my patient with my cancer drug, but I do not know how to sell hope to the investor. So this is maybe one skill that you can learn from your mentor who are investor and business people that you have to learn from. But we were successful. We enough to get funding from the investor. We actually expand to Thailand. We built a Thailand lab because that is actually what you use the invested money for, and then we expand our business that way. And from that, we also had a Hong Kong team member, Kelly, who worked with Tony before, that to actually manage the Thailand lab for us. And then for that, we got multiple partners working quite well. And then this is a summary. We had a valuation about 330 million at that time. However, always some disaster number 2, COVID. Medical facilities shut down, no more investigation, no more blood tests, no more income. So what do you do? And also at that time, there's also a company in Taiwan called ACT Genomic doing the same thing. A company from Singapore called Lucent doing the same thing. So when you got 3 groups, well, partner with one. That's always a thing. So sleep with your enemy is the right thing to do. So basically, you can see that at COVID, I slept with my enemy. I actually joined ACT from Taiwan and also our company together. So that is merging. And you can see Sunny here to witness our merging, our marriage. We expand around the Asia area, which is actually quite good, doing very good business, at that time, and then to improve the market landscape. So that is my experience among the multiple small disasters. Those are the two major disasters. Now quickly, time not much left, my exit plan. All business must have exit plan. It's not just for the finance of it, because you have to move on to the next thing. If you don't have an exit plan, you don't know what you want to do in the so-called the next step. So you must have an exit plan in place. So there are all kinds of exit plans. I'm not going to do the business people. I'm not going to go through it, but I can tell you what I do. The easiest way is to sell it. Kinetic make a lot of money during COVID by doing the COVID testing. So they got a lot of cash. They need more business to expand. I sold it to them. Well, and a little bit discount price, but that's okay. I can get rid of it. But then, you know what? They don't give you money. They give you some money. They give you paper. They call shares. I don't know whether you should believe in those paper or not. A lot of times they just fool you that this is a paper that worth some money. So I have to make sure those paper worth something. So I don't entirely trust Kinetics management. So I kind of work together with Dennis to say, hey, Dennis, you got a new technology of early detection. Kinetic got the money, and then I got some Kinetic share. Why don't we put together and become the Insider? And then we do have some people from Insider here. And then so Kinetic invests the money, and then Dennis Lowe's team invests the technology. And Insider, I can tell you, is doing really good. If you really want to invest something, you better talk to Dennis. So, and also, in the same time, it's interesting, the company that I signed in 2015, that I sold and merged, and then sold to Kinetic, Kinetic turned it around and sold it to a electronic company in Taiwan. So now, it is actually owned by an electronic conglomerate in Taiwan for the price of X amount. And I'm sure that Danny will make money out of that. So I think that I have actually learned a few lessons from this process. Number one, I think right now we are all friends. But when you come to investment, you have to know who is friend, who are just investor, or who are friend who invest, who are investor is a friend. Sometimes it's difficult to distinguish. Some people I met during the journey, I never see them again when I don't have a company. Some people, you know that they're friends, for long, like Dennis and Alan, we're still very good friends. But then the other thing I learned that I never learned as an academic is a lawyer at counter your dialogue. Every time you see them, you bow. Because without them, it's impossible to run an entrepreneurial company. So please find a friend who is doing a lawyer or IPO. And IPO, to me, I thought about IPO, but then I looked into the process. Sometimes it's such a difficult thing to do. That may not be your dream. I mean, to me, it's actually more realistic if someone can buy a company. But another thing is that if you do want to so-called sell a company, you have to maximize so-called the share value. Now, last but not least, I want to share with you today is that we love science, but we do science for the sake of science. But then there's potential opportunities. Science can be converted to technology. But if you want to convert that, it's likely going to be a long journey. The first thing is to say that what is your novel technology? What is the clinical relevance before you engage in the commercial opportunity? And also in your basic business plan, you have to say what's the business model, find a place, and find some seed money to do that. But more than important is that you have to know that you have a strong team at your back. And also, disaster will happen, expect it to happen. But it is always a learning experience if you're able to overcome this disaster and eventually lead to some degree of success. So under the note, I thank you all for the attention. I want to say one last word is that it's not just that you have to convert science into commercial. Sometimes you can convert your hobby into commercialization as well. This is a restaurant I invested a bit in, 10樓 Times Square. 記住去啦，賣燒豬嘅。Thank you so much. Thank you.